Hi everyone, welcome back to my channel. This is a completely homemade alarm clock that I built from plywood and some simple parts that I bought online. Everything is custom, including the circuit board, which I designed, soldered, and programmed myself. I wanted to recreate a simple appliance that most people own and make it overblown and eye-catching. If you want to learn more about how this was done, please stick around, and if you want to help me out, please like this video and subscribe. That would be awesome. So this is the design I will be cutting out of that piece of 1/4-inch plywood. I drew it in a software program called Rhinoceros. I'll include a link to their website in the description. You can see I placed holes for all the components I plan to use, then I linked them together with this cool spiderweb design. I had no particular reason to do this other than I wanted this clock to be big and eye-catching, and I think I accomplished that. I'm now going to screw the plywood down on my routing table real quick, and then I'll start cutting. Alright, now that the plywood has been shaped, I'm going to start coloring the grooves with these Sharpies. If I'm careful, I should be able to do a decent job without marking the top layer of the wood. I've noticed the ink likes to bleed into the fibers, so as long as I don't push too hard, I should be able to do a decent job. Now with the coloring done, I'm ready to start adding components. These are the LEDs I'll be using for the 6-digit display. Once they're placed in their holes, I'll start bending and soldering the pins together. You can see here I'm soldering the LEDs into groups of 4. These displays are called 7-segment displays, and each LED grouping represents a single segment. Each segment is represented by a letter, so if I wanted to write 3, I would tell my computer chip to light up segments A, B, C, D, and G. I'm going to be explaining why this is all important once I start assembling the circuit board. Here are the rest of the components I need to install. It's just 2 large push buttons, a dial, and a buzzer. The buttons are for snoozing or silencing the alarm. The buzzer will make the alarm sounds, and the dial will allow me to adjust how bright the LEDs will shine. With all of my wiring completed, I'm ready to start talking about the circuit board. Creating a board is a multi-step process. You start by designing a schematic where all the electrical parts are laid out and the connections between them are drawn. You can see the computer chip and all the surrounding hardware, which provides control over the LED display. If I were to cover every detail of designing this circuit, my video would be hours long, so I'm keeping this simple. Once the schematic is finalized, the next step is to add physical dimensions. Here you decide the size of your circuit board, where the parts are placed, and add holes for mounting screws. Once the design is complete, it can be submitted to a manufacturer who should mail your physical board to you within a few weeks. I use an online company called Oshpark.com for the manufacturing, and the design software I'm using is Autodesk Eagle. There will be links in the description for these websites as well. Before I start connecting wires to my circuit, I want to better explain how it controls the LED display. As a reminder to all the non-electrical engineers watching, an LED light will only illuminate if its two pins are connected to a positively charged source on one side and a negatively charged source on the other. A battery is a perfect example of a power source that produces a positive and negative charge. Remember, electricity has to flow in a loop, so if there is a break anywhere in the circuit, our LED bulb will not illuminate. Now we can use that particular detail to control our display. There are 13 wires total. 6 are used to select which digit you wish to illuminate. Each of these wires are connected to a pin on every LED within that respective digit. The other 7 wires are used to select which segments of the selected digit you wish to illuminate. You'll remember that segments are the individual LED groupings that make up each digit, and that they were labeled using letters A through G. Now let's show an example of how this will work. Say all I wanted to do was illuminate segment G on the first digit. I would start by applying a positive charge to that digit's selection wire. This means that only the segments in digit 1 get a positive charge. Next, I'll apply a negative charge to the wire that is connected to the G segments in all digits. Even though all the G segments in all digits are getting a negative charge, only digit 1 has the positive charge, so only the G segment in digit 1 illuminates. Keep in mind, I'm using the colors red, blue, and black to indicate what charge is applied to each wire. If the color is left black, it means there is no charge, or it simply means it's disconnected. Now remember, in order to display the number 3, you have to apply a negative charge to segments A, B, C, D, and G. This you'll see shows the number 3 in the first digit. If I wanted to display a 3 in a different digit, I would apply a positive charge to a different digit selection wire. If I wanted to display a 4 in more than one digit, I would apply a negative charge to segments B, C, F, and G, and a positive charge to more than one digit selection wire. Now say I wanted to display an 8 to all the digits, then I would apply negative charges to all the segment wires and positive charges to all the digit wires. This you'll see lights up all the segments in the display. If you look at my board, you can see that there is a 6-pin connector for the digit selection wires and a 7-pin connector for the segment selection wires. Once the wires are attached and the circuit is bolted to the wood, I just have to program the computer chip and this clock will be done. Alright, after about a month and a half, this clock is finally done. Everything is working. I can turn alarms on and off. The press of this button right here, or these two buttons, I can turn the alarms on and off. I can adjust the brightness of the display by turning this knob. It'll get brighter. I don't know if you can see that. I can certainly see it. If you turn it all the way down, it'll turn off. There you go. These are my buttons right here. Little aluminum rods that I've got sticking through the wood. I can press them and they click. I can adjust the time by holding down the time button. I hold down the time button and the time will begin to flash. And then by pressing the hour and minute buttons, I can adjust what hour it is. 1, 2, 3, 4, 5. What time is it? It is 7. I can adjust the minute to 43. There you go. Hold down the time button. It stops flashing, and it is now displaying the correct time, 7:43. There, see? I know it kind of looks like the display is flickering, and it's kind of swooping from the right side to the left. That is an optical illusion that has to do with the frame rate of the camera. To the human eye, to my eye, it looks perfectly normal. This clock has been a much bigger project than I was anticipating. I gotta be honest, I'm very glad to see it done. I suppose the last thing I've got to do is show you what it looks like when the alarm triggers. And that's it. Thank you all for watching. Please remember to subscribe and enjoy your day.